Okay, so we're moving on to chapter 4. We're finally done with exponential equations. And this one, it is telling us that someone is standing at the top of 1,450 foot tall Sears Tower in Chicago. And they're dropping a baseball from the roof, and they model the height of the ball in feet as a function of time. So given a certain amount of time, how high is it? It gives me the function, which is h of t equals negative 16t squared plus 1450. So what I want to go ahead and do is I want to go graph that. So I know you guys don't have your graphing calculators at home, so I'm going to go do this in Desmos. And instead of h of t, I'm going to do y equals, and instead of t, I'm going to do x. So right now I'm just focusing on completing my table. So what I can do is if I hit settings and then I can convert it to a table, it'll give me a table of values. So I don't need these two values, but I do need 3, 4, 5, 6, 7, 8, 9, 10. So I just hit enter and it keeps populating those values for me. So what I'm going to do is, starting here at the 1450, going down, I'm going to copy those numbers onto my chart. Okay, so I have finished copying this on my chart, so I'm going to go back to my paper. It wants to know how far it has fallen during the first second. So what this is saying is I've gone from 1450 feet to 1434. So I need to subtract. I can't type. Type, right? Talk? Can't do anything. 1434. Which will give me, if I type it on a calculator, it'll give me 16 feet. So, this is the difference between the initial height and the first second. I'm going to do the same thing with number 3. This is where I can't type. This should say fall. During the second. So what I'm going to do is I'm going to do 1434 minus the second was 1386. So I'm going to do that on the calculator. And by calculator, I mean my phone calculator. Gives me 48 feet. This one, I'm going to write this in green. This is the difference between the first second and second second. So this one wants us to find the rate of change, which is the change in output divided by the change in input. So the change in output was our answers for 2 and 3. So this was 16 over, I'm going to have 1 minus 0, which gives me 16 over 1, which is still 16. And over for number B, I'm going to use number 3, so that's 48 over 2 minus 1, which is still 1. So I get 48 as my answer for B. Okay. Moving on to the back. Based on our answer for number 4, do we think it's a linear function? A and B were different values, so no. The rates of change have to be the same for it to be a linear function. I want to go graph this, and I'm going to use those window parameters, so I'm going to go back to Desmos. I want to change this back to, no. Can I change it back to the function? Okay, I'll just type it again. No. Okay, so what I need to do on Desmos to change it is over here in this corner you see this little wrench. It's my graph settings. I have my x-axis is set fine. The x-min is -10, the x-max is 10. For my y-axis, I want to change the bottom number to -50. And for the larger of the two numbers, I want this to be 1500. And then I want the wrench to go away. So here is what my graph looks like. You can't see it all because of the recording window, but right there. Okay, so I'm going to go sketch this graph on my paper. And then what did the graph actually look like? Oh, it wasn't. So kind of like that. Okay, so we would describe this as the shape is an upside down U. It is symmetric across this way is y-axis. And let's see. It has x-intercepts at, so I'm going to switch back to my graph really quick. I need to go down here. So my x-intercepts are at 9.52 and -9.52. And a y-intercept at, so I want to look back up here, and it is at 1450. Okay, the practical domain and range of this height function. So I can't go back in time for my function. So the practical domain is 0 to 9.52. And the reason it stops at 9.52 is because that's when it goes below ground level. You can't go below ground level. So the practical domain is 0 to 9.52. And the practical range is, this one's a little bit harder to tell. So my highest y value was 1450, my lowest y value was 0. So it's 0, oh, I wanted this 0, to 1450. Okay. Is the graph of the height function the actual path of the object when the ball is dropped? No. The ball speeds up the longer it's falling. Kind of think of this as more of a graph that is showing me how fast it's going. The graph, the U shape is called a parabola. If it's looking like a U, it's opening upward. If it's going down, it looks like kind of like a lowercase n without the little thing. So, what I want to do on number 10 is, nope, I haven't finished reading things. So if it's got a squared in it, it's called a quadratic function. It has three terms. There's a quadratic term, ax squared, a linear term, bx, so the one without an exponent, and a constant term, the one without an x at all. The numbers in front are called coefficients. So, as long as I have the x squared term, I don't have to have the other two. I can have a combination of them, or I can have none of them, or both of them. So, my a value for here is the number in front of my squared. This one is 3. There's no b value, no c value. Okay. The next one, my a value, is the number in front of the squared, so that's negative t, 2, negative 2. B, I don't have a number with x, so it's 0. C, I have a number with 3, I have a number without a letter, so that's 3. On the next one, this one has a secret number out front of 1, so my a value is 1, my b value is 2, my c value is negative 1. For the last one, this has also got a secret 1 out front, so it's negative 1, 4 for my b value, and 0 for my c because I don't have a regular number at the